Hello, I'm Boyao from Inria. My supervisors are Jean-Sebastien Franco and Edmond Boyao. I'm working closely with Federica Bogo, Buka Taken, and Martin de la Gorce in Microsoft. Today my topic is reconstructing 3D human with learning-based method. In the telepresence application, the AR-VR system could capture the depth image on the top, for example. Our goal is to reconstruct human 3D meshes on the bottom. To consider the human shape, human pose, and clothes style, this problem could be challenging. To solve this problem, we come up with learning-based method plus implicit representation. First, why we need deep learning here? The data-driven method can help completing partial input data, for example, depth image. Second, why we need implicit representation? On the bottom, we give the basic concept of implicit function. Given the query point, the implicit function could predict the occupancy probability whether that point is inside or outside of the surface. So the implicit function is a weakly constrained shape model which can handle dressed person. Third, what is a novelty in this work? We leverage the information over time to reconstruct human motion. Concretely speaking, we take a sequence of depth image as input. We want to learn a function to predict occupancy value at any time step t and at any point position p. To end this, we propose a three-stage network architecture. In the first stage, our encoder embeds the depth image into feature maps f1, f2 to fn. In the second stage, our network could interpolate temporal feature at time step t. Finally, our occupancy decoder predicts the occupancy value at point p and time t. We call this model Steve. Here we show some qualitative results. On the left is the raw scan data from dynamic forced and cape dataset. On the right is the reconstruction of our Steve. In the middle, they are the results of the static models. You can see here, our dynamic model could better preserve the volume of human. We give a human motion video for spatial completion task. Our dynamic model can not only complete the partial data, but also add more intermediate frames into the motion sequence. For example, on the left, we give a low frequency motion sequence. On the right, with the enhancement, the motion can be smoother. Thanks for your attention.